Hello and welcome to Virtual Learning Network. This e-lecture is on Computer Basics and PC Software, Block 3rd, Unit 1, Introduction to Networking and Internet. The topics we are going to cover are Introduction, what is a computer network, data transmission channels, network topologies, network classification, reference models, Internet and its software components, Internet addresses. Last one is summary. Let's start with introduction. The computer network made various computers to share information at a very high speed. The Internet could carry any digital signals such as text, graphics, sound, video and animation. Internet has thousands of networks and millions of users, with the numbers expanding daily. Now, what is a computer network? A computer network can be simply defined as the interconnection of two or more independent computers. Applications of computer networks are found everywhere. They are used in our houses, schools, colleges, railway stations, offices, and businesses. They help us to send an email, watch a live sports event at our computer, book rail or air tickets, and do chatting with our friends. There are some advantages of using computer network. First one is resource sharing. A network is needed because of the desire to share the shareable programs, data and equipment available to anyone on the network without regard to the physical location of the resource and the user. Next one is high reliability. A network may have alternative source of supply. In case of one resource failure, the others could be used and the system continues to operate at reduced performance. This is a very important property for military, banking, air traffic control and many other applications. Next one is cost-benefit advantage. It is also a main advantage of computer network. Last one is scalability. The ability to increase system performance gradually by adding more processors. The Internet. Internet is an interconnection of thousands of networks. One of the major applications of the Internet is the World Wide Web. The WW provides a point and click interface to text, images, sound and movies. That has proven to be very easy to use. The Internet is a collection of various services, tools, applications and resources. Some of the popular services on the Internet are browsing, searching, email, chat, e-learning and loads more. Data communication system. In the most fundamental sense, communication involves implicitly the transmission of data or information from one point to another through a succession of processes. Data is transmitted over any communications medium as either digital or analog form. The most important factors affecting the transfer of a signal over a medium are noise and attenuation. A simple communication system can be presented by the block diagram as shown below. The communication system essentially consists of 5 parts. First one is source. Source produces a message or sequence of messages to be communicated to the receiver. The source output may be in many different forms, such as waveform, a sequence of binary digits, and a set of output from sensor in a space probe, or many other similar forms. Second one is an encoder. Encoder represents any processing of the source, messages or signals prior to transmission. The processing might include, for example, any combination of modulation, data reduction, and insertion of redundancy to combat the channel noise. Channel is the medium for transmitting signals from transmitter to receiver. It may be a telephone line, a high frequency radio link, a space communication link, or a space medium. A channel is usually subject to various types of noise distributions, which on telephone line, for example, might take the form of a time-varying frequency response, cross-talking from other lines, thermal noise, and impulsive switching noise. A channel subject to noise is called noisy channel. An error correcting code corrects error due to noise. Next one is the decoder. A decoder represents the processing of a channel output received from the channel to produce an expected replica of the input at the destination. The last one is the destination. Destination is the receiver. It may be the person or object for whom the message is intended. There are several modes of data transmission. There are three types of data communication: simplex, half duplex, full duplex. In simplex mode of data communication, data flow is unidirectional. This means that data travels only in one direction, from a sender to receiver. The sender cannot respond back to the sender. An example of simplex mode is keyboard or a television station telecasting a program. Next one is half duplex mode. Half duplex communications occurs when data flows in both directions, although in only one direction at a time. An example of a half duplex system is a walkie-talkie system, used a two-way radio normally by police. You may use the word over to indicate the end of transmission and induce that only one party transmit at a time. In such systems, senders and receivers both transmit on the same frequency. Last one is full duplex mode. In full duplex mode of data transmission, data is transmitted in both the directions simultaneously. This means that both the devices in a network can send and receive the data at the same time. It is like a two-lane road with traffic moving in both directions at the same time. In this mode, signals going in either direction share the capacity. Half of the bandwidth is used for sending data in one direction, while the other half is used for receiving data from other direction. An example is our telephone conversation. Packet and circuit switching. This terminology has started from telephone network, where switching offices were places having switches that were used to create connection from one source to destination. Circuit switching involves creating a switched path for entire communication. For example, when you make a telephone call, the connection is established by switching and is available for the whole communication, whereas in packet switching, a message is broken in small packets which are handled over from a source to destination through many small steps. Data transmission channels. The data transmission has to be done over a transmission channel or media. It can be classified as guided channel, unguided channel. First one is guided media. Guided media provide a physical connection between two devices. A signal traveling through guided media is directed and contained within the physical limits of the medium. There are several different guided media: twisted pair cable, optic fiber cable. Let's start with twisted pair cable. A twisted pair cable is still the most common transmission media. A twisted pair cable consists of two conductors which are normally made of copper. Each conductor has its own plastic insulation, typically 1 mm thick. These cables are twisted together. The wires are twisted in a helical form similar to a DNA module. Twisting is done to reduce crosstalk. The performance of the twisted pair can be substantially improved by adding a metallic shield around the wires. Shielded wires are much more resistant to thermal noise and crosstalk effects. Twisted pairs are used for long distance connections. Example, telephone line, which are usually organized as large cable containing numerous twisted pairs. Next one is optical fiber. An optical fiber consists of two concentric cylinders, an inner core surrounded by a cladding. Both the core and the cladding are made of transparent plastic or glass material, which transmits signals in the form of light. Optical fiber use reflections to guide light through a channel. The density of the core and cladding must differ sufficiently to reflect the beam of light instead of refracting. The core is used for guiding a light beam, whereas the cladding acts as a reflector to prevent the light signal instead of electrons. It does not suffer from the various noise problems associated with electromagnetic signals. The signal is usually generated by a laser or LED. Optical fibers can provide bandwidth to distance ratios in order of hundreds of megahertz per kilometer. Like other cables, hundreds of optical fibers are usually housed within one cable. Now, unguided media. Unguided media is used for transmitting the signal without any physical media. It transports electromagnetic waves and is often called wireless communication. Signals are broadcast through air and received wireless communications. Signals are broadcast through air and received by all who have decided to receive them. It can be categorized as follows: radio waves, microwaves, infrared. Now, radio waves. Electromagnetic waves ranging in frequencies between 3 kHz and 1 GHz are normally called radio waves. Radio waves are easy to generate and can travel long distance and can penetrate buildings easily. Therefore, widely used for communication. These are omnidirectional, which implies that these travel in all directions from the source. So, the transmitter and receiver do not have to be carefully aligned physically. Radio signals have been used for a long time to transmit analog information. Bluetooth is a very popular application of short wavelength radio transmission in the frequency band of 2400 to 2480 Hz. It is a proprietary wireless technology standard used for exchanging data over short distance in mobile phones and other related devices. It allows wireless devices to be connected to wireless host, which may be a computer over short distance. Now, microwaves. Electromagnetic waves ranging from 1 to 300 GHz are called microwaves. Microwaves are unidirectional, that is, the sending and receiving antennas need to be aligned. Microwave is by far the most widely used form of radio transmission. It operates in the gigahertz range with data rates in order of hundreds of Mbps per channel. Telecommunication carriers and TV stations are the primary users of microwave transmission. An important form of microwave system is a satellite system, which is essentially a microwave system plus a large repeater in the sky. Last one is infrared. Infrared signals are generated and received using optical transceivers. Infrared systems represent a cheap alternative to most other methods because there is no cabling involved and the necessary equipment is relatively cheap. Data rates similar to those of twisted pairs are easily possible. However, applications are limited because of distance limitations. One recent use of infrared has been for interfacing handheld and portable computing devices to local area networks. Network topologies. Network topology is the study of the arrangement or mapping of the elements of a network interconnection between the nodes. It also determines the strategy for physically expanding the network in future. Topologies can be physical or logical. Physical topology means the physical design of a network including the devices, location and cable installation. Logical topology refers to the fact that how data actually transfers in a network as opposed to its design. There are a different type of the technologies like bus, ring, tree, mesh, etc. Let's start with bus topology. Bus topology is a single common communication to which all the computers are connected. It has a single length of cable with a terminator at each end. The bus topology is the simplest and most widely used with local area network design. Ring topology. Ring topology is also known as a circular topology. This layout is similar to the linear bus except that the nodes are connected in a circle. In this topology, each node is connected to two and only two neighboring nodes. This type of topology can be found in peer-to-peer networks, as shown in this figure, in which each machine manages both information processing and distribution of data files. Star topology. In star topology, each computer on a network communicates with a central hub that resends the message either to all the computers or only to the destination computer. A hub expands one network connection into many. Network classification. There are mainly three types of networks. LAN, that is known as local area network. MAN, metropolitan area network. WAN, wide area network. Let's start with LAN. LAN is a group of computers located in the same room, on the same floor, or in the same building that are connected to form a single network. Has to share resources such as disk drivers, printers, data, CPU, fax or modem, applications, etc. LAN is generally limited to specify geographical area less than 2 km. Supporting high-speed networks, a wide variety of LANs have been built and installed, but a few types have more recently become dominant. MAN, Metropolitan Area Network. MAN, Metropolitan Area Network or MAN are large computer network that spans a metropolitan area or campus. Its geographic scope falls between a WAN and LAN. They typically use wireless infrastructure or optical fiber connections to link their sites. A MAN is optimized for a large geographical area that a LAN, ranging from several blocks of buildings to entire cities. MANs can also depend on communications channels of moderate to high data rates. MAN provide internet connection for LAN in a metropolitan region and connect them to wider area networks like the internet. The network size fall intermediate between LAN and WAN. A MAN typically converts an area of between 5 and 50 km diameter. Many men cover an area the size of a city through, in some cases, mans may be as small as a group of buildings or as large as the north of Scotland. A man often acts as a high-speed network to allow sharing of regional resources. It is also frequently used to provide a shared connection to other networks using a link to a WAN. Wide Area Network WAN. It is a network system connecting cities, countries, or continents. A network that uses routers and public communication links. The largest and most well-known example of a WAN is the Internet. WANs are used to connect LANs and other types of networks together so that users and computers in one location can communicate with users and computers in other locations. Many WANs are built for one particular organization and are private. Reference models. One of the most difficult software to be developed is the networking software. Reference models were designed to standardize the layers of functions and activities. OSI, Open System Interconnection Model. The OSI model is an abstract description for layered communications and computer network protocol design. Open system means that it can communicate with any other system that follows the specified standards, formats, and semantics. Protocols give the rules that specify how the different parties may communicate. In its most basic form, it divides network architecture into 7 layers, which from top to bottom are the application, presentation, session, transport, network, data link, and physical layers. It is therefore often referred to as the OSI layer model. Now, this diagram shows OSI model layers. First one is physical layer. This layer provides the functional requirements for activating a physical link. In this layer, data is carried from one device to another. Next one is data link layer. This layer provides physical identification of a device using media access control address. It adds source and destination address to packets and convert them into frames. This is the layer that provides error-free transmission. Network layer. This layer translates logical address into physical address. This layer also fixes the route for data path. Router works in this layer. In this layer, data is called a packet. Next one is transport layer. This layer converts data into segments and reassembles the data stream. TCP and UDP are the protocol used in this layer. In this layer, data is converted into so-called segments. Next one is session layer. This layer manages connections between different application layers. Next one is presentation layer. It converts the data into suitable formats. It thus takes like compression, decompression, encryption, and decryption. Last one is application layer. This layer is the layer for user interaction. We must have application software for dealing with the data. Now, networking devices. First one is network interface cards. The network interface card provides the physical connection between the network and the computer. Most NICs are internal, with the card fitting into an expansion slot inside the computer. Network interface cards are a major factor in determining the speed and performance of a network. It is a good idea to use the fastest network card available for fast transfer of data. The most common network interface connection today is Ethernet cards. Next one is modem. A modem is a communication device that converts binary signal into analog signals for transmission over telephone lines and converts these analog signals back into binary form at the receiving end. You can use a modem to send data and files to other computer. Users using standard telephone lines, you can transfer data, exchange electronic files, and even carry on a typed conversation in a real time. Repeaters. When a signal travel a network cable, they lose strength, degrade, and become distorted in a process that is called attenuation. A repeater is a device that electrically amplifies the signal it receives and rebroadcasts it. They are used when the total length of your network cable exceeds the standards set for the type of cable being used. Bridges. Like a repeater, a bridge can join several lanes. However, a bridge can also divide a network to isolate traffic problems. For example, if the volume of traffic from one or two computers or a single department is flooding the network with data and slowing down entire operation, a bridge can isolate those computers or that department. A bridge is used to connect two segments, segment 1 and segment 2. Each segment can have several computers attached to it. Hubs. A hub sends any data packet coming from one port to other port. It is up to the receiving computer to decide if the packet is for it, typically used to connect segments of a local area network. A hub contains multiple ports. Hubs are typically used on small networks where the amount of data going across the network is never high. A hub is typically the least expensive, least intelligent, and least complicated of the hub. Router and switches. Every computer connected to the hub sees everything that ever other computer on the hub sees. Switch. A switch does essentially what a hub does, but more efficiently. By paying attention to the traffic that comes across it, it can learn where particular addresses are. For example, if it sees traffic from machine A coming in on port 2, it now knows that machine A is connected to that port and that traffic to machine needs to only be sent to that port and not any of the others. The net result of using a switch over a hub is that most of the network traffic only goes where it needs to rather than to every port. On busy networks, this can make the network significantly faster. A switch is a device that can segment a larger local area network to reduce the traffic load. Routers. A router translates information from one network to another. It is similar to an intelligent bridge. Routers select the best path to route a message based on the destination address and origin. The router can direct traffic to prevent head-on collisions and is smart enough to know when to direct traffic along shortcuts. Gateway. Gateway interconnects networks at higher layers than bridge or routers. A gateway usually supports address mapping from one network to another and may also provide transformation of data between the environments to support end-to-end application connectivity. Gateway typically limits the interconnectivity of two networks to a subset of the application protocol supported on either one. The main function of a gateway is to convert protocols among communications networks. A router by itself transfers, accepts, and relays packets only across networks using similar protocol. A gateway can be implemented in hardware, software, or both, but they are usually implemented by the software installed within a router. A gateway must understand the protocols used by either network linked into router. Gateways are slower than bridges, switches, and routers. Internet and its software components. Internet is a global connection of network. The internet is basically built up of multiple smaller networks called the subnets. Each computer systems on a subnet must have a unique address. All these subnets are connected together with network device called routers, and each subnet may also contain its own subnets. To connect to a physical network, all the devices, irrespective of being wired or wireless, uses an interface card. An interface card may have its own unique physical address. TCP and IP are the two core protocols of the Internet Protocol suite. The TCP primarily provides the reliable delivery of stream of bytes from a computer or a program to another computer or a program. It breaks the data stream into packets at the source and makes sure that all the packets are assembled orderly at the destination. The IP protocol, on the other hand, identifies the location of source and the destination. Any computer on internet is identified by its unique IP address. Currently, two standard versions of IP are available. Internet Protocol version 4, IPv4, which is currently being used on most of the internet, and IPv4 address is a 32-bit address. Second one is IPv6, Internet Protocol version 6. www is one of the major applications of internet and is based on the concept of hypertext, that is hot link to a document that may reside on any website. It is a global infrastructure of connected documents. Following are some of the major software components required to access internet. Software, internet browser, TCP/IP protocol. TCP/IP model. Just like the OSI model, the TCP/IP model has many layers which are described below. Host-to-host network. In fact, TCP/IP model does not specify this layer, but it basically combines functionally of physical and data link layers. Starting at the bottom, the physical layer is what deals with hardware utilizing the existing physical layer. TCP/IP does not define its own, thus letting the layer 2 compatible with all network suites. This layer are also encoded and transmit data over network communications media in the form of bits, which are received by the physical layer of the destination device. Often combined with this layer is the data link layer, which is responsible for moving packets from the network layer onto the different host. Depending on the connection type, IP packets are transmitted using various methods. Dial-up modem transmit IP packets using point-to-point protocol, while broadband user transmit using POP, internet layer. This layer routes and delivers data across similar networks or completely different networks. The network layer is responsible for end-to-end packet delivery while maintaining routing, flow control, and error control functions. An example of this layer is the Internet Protocol or the Internet Protocol security. Transport layer. The network layer can be thought of the actual vehicle which transports information. This layer categorizes end-to-end message transmission or connecting application as either transmission control protocol or user datagram protocol. TCP is a connection-oriented protocol which is considered to provide a reliable byte stream. Some characteristics of TCP are traffic congestion control, data arrives in order, data has minimum error, and duplicate data is discarded. Internet addresses. IPv4 address is a series of 4 numbers separated by dot. The 4 numbers range between 0 and 255. So IPv4 address takes only 4 bytes of computer memory. Not all the IPv4 addresses may be used to identify a computer. Some addresses of IPv4 are not used at all due to certain restrictions. In addition, some addresses are restricted. For example, if IP address 255.255.255.255 is used for broadcast, every device, computer, printer or peripheral connected to a TCP/IP network must have its own IP address. Each 32-bit IP address contains of two components. First, net ID, second, device ID. Net ID, network identifier, which identifies one of the networks that is a part of internet. Device identifier, which identifies a specific device within the identified net ID. A net ID may be of 8 to 24 bytes long. By using a subnet mask in combination with their own IP address, you can identify the destination address of the device is remote or local. For example, consider the IP address 192.168.1.35 having 24 bits net ID. The remaining 8 bits of these address specifies the device ID. The subnet mask for this network should be 255.255.255.0. This subnet mask is used to identify the IP address of the network. Here are some examples of IP address subnet mask. Number of IP addresses. DNS and web addresses. DNS and web addresses. Web address is used to view a web page. When you are viewing a web page, the web address of the page appears in the address bar in the browser. In the previous session, you have gone through the concept of IP addresses. DNS, domain name system. DNS should keep track of address of each computer or any other internet device and email addresses. The name servers translates the web address or email address to respective IP address. For example, the name server translates address like www.ignu.ac.in into a computer understandable IP address. Email addresses. Email is one of the popular services increasingly being used by people in their daily life. The following can be a typical email address format on internet for any email service provider like Gmail, Rediff, Yahoo, MSN or any other network name, etc. Summary. This unit is an effort to answer some of the various basic questions about the data communications, networking and the internet. Network topologies define the basic structure of the network. These basic network topologies, bus, ring and star, have been defined in this unit. The networks can also be classified on the basis of their characteristics. LAN, WAN, MAN fully described in this unit. Thank you for this session.